Okay, these are video solutions to unit test 1. Um, these are going to be probably questions 1 through 4, just so we don't get too long. Question number 1 gives us a 2t squared um, minus 50. And of course, on all these exercises, the job is to factor completely. The first step, you see the common multiple of 2, you factor out the 2, and you got 2 times t squared minus 25, and then you're looking at a special case, you're looking at a difference of squares, and so factoring that perfect situation, we get t plus 5 times t minus 5, and shouldn't be much of a problem with that exercise. We didn't see anything in the data where people were missing that one, so that was all good. The next one, the 2x squared plus 5x minus 12. Again, just an expression that we're trying to factor here. You probably can factor this using a reverse FOIL technique, something of that nature. Um, Instead, what I'm going to do is use the AC method that we discussed, because we find a couple students were asking to see more of it and see it done some more. So the AC method refers to multiplying the A value and the C value. So in this case, 2 times 12 is 24. And then after generating that AC product, you look at all the factors of that AC product. So that would be 2 and 12 and 4 and 6 and 8 and 3. Those would be all your integer factors of 24. And then you compare those values to B. And in this case, B is a 5. And since we would have different signs in our factorization, said by the minus 12, we would want to use the 8 and the 3 pairing. And then the next step in this AC method is to expand the middle. So the plus 5x would be written in some order as a plus 8x and a minus 3x. Again, you could have the minus 3x first, have the plus 8x follow it if you'd like. And then after you get to this stage, after you've expanded the middle term, it comes down to factoring by grouping. And so we factor out from the first pairing both a 2 and an x, and that leaves us with an x and a plus 4. And then from the next pair, a minus 3x and a minus 12 is going to factor out the multiple minus 3. And by factoring out the minus 3, that leaves us with a pairing of an x, of course, because minus 3x divided by minus 3 is just x, and minus 12 divided by minus 3 is 4. In fact, you want to keep in mind that when you're factoring, what you're doing is you're dividing. You're basically doing the old arithmetic factor tree kind of a thing. Now, at this point, you see that both pieces that we just factored ended up with a factor of x plus 4 individually. And so our final step is to write out that x plus 4 to divide each term, that is, by that x plus 4. And when you do that, on this first pairing, 2x times x plus 4, if we divide out x plus 4, that's going to leave us with just a 2x. And of course, the minus 3 times x plus 4 divided by the x plus 4 yields a minus 3. So there's your final answer in some order. You might have had the 2x minus 3 times the x plus 4 um, first, but by commutativity, of course, the order doesn't matter. Question number 3 is, first may be alarming because you have a cube in it, not typically the stuff of the basic high school realm. But as you look this thing over, and if you go back to basics on these things and look for that common factor, um, and think about pairwise factoring, think about factoring by grouping, this one becomes pretty easy. The first pair, of course, have a y squared in common, and I'm going to remind you that when you're factoring, factor out the lowest power you see, and you have y cubed, and I have y squared, so we factor out the y squared. And when you divide a y squared out of each of those terms, you're left with a y minus 3 on that pairing. And then the minus 4y plus 12, going to factor out a minus 4. And dividing out a minus 4, we're left with a y and a minus 3. And finally, a y minus 3 and a y minus 3 belonging to each of those, you're left with y minus 3 times y squared minus 4. And we did get a number of people that just left their answer like that. And of course, that's going to cause a problem because it isn't complete. The y squared minus 4 factors further. The y squared minus 4 factors to y plus 2 times y minus 2 as a result of them being a conjugate pair, a difference of perfect squares as it is known. And so final answer on that one in some order should have been y minus 3 times y plus 2 times y minus 2. So that's question number 3. And then we'll finish up this video with question number 4, which gives us an x to the 4th plus 27x. And a few people, more than we'd like, divided out the x out of each term, left with x cubed plus 27, called that their final answer, which is factored, but it's not factored completely because x cubed plus 27 actually factors further. And if you think about this, and I'll just take this over here, I guess, and ask you to think about this way. If x cubed plus 27 was equal to 0, right? Well, you could determine that x could be a minus 3. That minus 3 is what they call a zero of the expression. Minus 3 makes the expression equal to 0. So if x minus 3 is a 0, then that tells me that x plus 3 would be a factor. And you're just doing that sort of reversing what you normally do when you solve equations. Bring the minus 3 back over to the side with the x by using the additive inverse. So what I know from that is that the x cubed plus 27, one factor of that is x plus 3. All right? Now there are other ways to determine the factors, and we mentioned things that aren't really required for the calculus, but you might be knowledgeable about, like Descartes' rule of signs and the fundamental theorem of arithmetic. But just trying to do this in sort of an intuitive fashion. If you have an x cubed and you know that one factor is x, it's pretty obvious. The other term is going to have a factor of x squared in it, right? Because x times x squared is where that x cubed is going to come from. And then likewise, if you have a last term here of 27, then down here, you're going to have a plus 9, right? Now, of course, that sets you up with your x cubed and it sets you up with your 27, but it also causes another term right here. That 3 times that x is going to cause a 3x squared. All right? Now, of course, the expression we're trying to factor, the x cubed plus 27, doesn't have any x squares in it. So if we gained 3x squared right here, then who could we put in this middle position to balance out that 3x squared, as it were? That is, to get rid of that 3x squared. And what I want to use is a minus 3x. Because when you put in that minus 3x, that causes, when it hits the first term, x times minus 3x is going to cause a minus 3x squared. And so the plus 3x squared that we caused will be balanced away, it will be zeroed out. Likewise, when the 3 is multiplied times the minus 3x, that's going to make a minus 9x, but it'll be balanced by the x times the 9, which will make a plus 9x. Now, there are other ways around that. Once you determine this factor of x plus 3, you can use polynomial long division or synthetic division. if we get requests to see more about how that's done, we can certainly produce something for you. At this point, you're algebraically prime. The x squared minus 3x plus 9 will not factor any further. And so that's going to be your final answer for number 4. We did have a substantial number of errors and a few questions about that. So that's how you do that question number 4. And if you need more help with it, by all means, let us know. All right, so we'll be back in just a minute with the video solutions for the rest of Unit Test 1.